Good evening, everyone, and welcome to Moving the Needle. My name is Kelly Goldberg, and I'm a member of the GI Research Foundation Board of Directors, and this year's Moving the Needle co-chair with Shelby Katz. Tonight is about momentum. It's about possibility, and most importantly, it's about people, patients, families, and all of you coming together to change what's possible in digestive health. On behalf of our whole organization, I want to thank you for being here. Your support isn't symbolic. It makes a real difference. It fuels discovery, it empowers scientists, and it brings us closer to breakthroughs that transform lives. Tonight, you will hear from the investigators whose work you make possible, leaders who are reimagining how we treat digestive diseases. These aren't just ideas. They are real advances happening now with the power to change patient care in meaningful, measurable ways. Guided by our extraordinary senior scientific advisor, Dr. David Rubin, investigators will share their progress, what they're learning, and where they're headed next. This kind of learning tonight and this kind of progress does not happen alone. So I'd like to take a moment to thank our donors and do a special shout out to Home Infusion Options for their ongoing support. I also want to recognize our fabulous board members, Emerging Leaders Council, and staff. Their passion and dedication are the engine that drives everything we do. What truly sets the GI Research Foundation apart is our deep and enduring collaboration with the University of Chicago Medicine Digestive Diseases Center, along with the extraordinary guidance of our scientific advisors, Dr. David Rubin, Dr. Eugene Chang, Dr. Cambrian Liu, Dr. Ashley Sidebottom, and Dr. Sushila Dalal. Their expertise ensures that every dollar invested is directed toward bold, innovative science with real potential to change lives. This partnership traces back to our founder, Dr. Joseph B. Kirsner, whose vision was simple but powerful: transform patient lives through research. That vision lives on tonight in this virtual room, in this work, and in the discoveries still to come. This partnership traces back to Dr. Joseph B. Kirsner, as I just told you. Please watch this short mission video with us. It provides insight into how we get our work done with your support.
Do you ever wonder how big medical breakthroughs actually happen? It all starts with an idea, just one question that sparks something bigger. Simple, right? Not quite. See, in reality, ideas alone don't change lives. Research does. And research, well, that needs funding. That's where the GI Research Foundation comes in. We are nimble. We take risks on bold new ideas. And we're not so big that funding gets stuck in red tape. We're independent, fast-moving, and committed to getting scientists the funding they need to turn big ideas into big discoveries and real treatments. The best part? It works. Research we fund attracts millions in major grants, leading to clinical trials, new treatments, and real breakthroughs. What starts here doesn't stay here. It grows, it scales, and it changes lives. Waiting years for funding and approval simply isn't an option for the millions suffering from digestive diseases. With your support, promising ideas can move beyond the lab. Ideas progress with speed and efficiency and lead to real treatments.
And now it's my pleasure to introduce someone who embodies our mission every day with extraordinary patient care and commitment to research. Please join me in welcoming Dr. David Rubin, Senior Scientific Advisor at the GI Research Foundation, Joseph B. Kirsner Professor of Medicine, Professor of Pathology, Chief Section of Gastroenterology, Hepatology, and Nutrition, Director, Inflammatory Bowel Disease Center, University of Chicago Medicine. Dr. Rubin.
Kelly, I want to thank you, Kelly, and also Shelby Katz for co-chairing the Moving the Needle event tonight. And I want to welcome everyone for joining us after a long day to learn a little bit about research, but also to be inspired the way I am every day, working with brilliant people trying to answer tough problems. The origins of Moving the Needle come from an idea we had a number of years ago to take what was happening in the labs and in our clinics and share it with our patients and our donors and our supporters in ways that would excite you and help you understand what we're trying to do to improve the lives of people who live with digestive diseases. This is a program that is supported by our dear friends at the Gastrointestinal Research Foundation. As you just heard, the GI Research Foundation has existed for over 60 years, funding research at the University of Chicago and to our partners in digestive diseases across the institution and in collaboration with others in other departments, divisions, and other universities, and even in industry when it's appropriate. And the GI Research Foundation has been indispensable at supporting new ideas, high-risk science, that can fund pilot data that leads to bigger discoveries and huge advances. And there are many examples of that over the years. Tonight, we've invited a few of the GERF-funded investigators to share with you in just a few slides each what they're doing and what critical questions they're trying to answer. So with that, let's kick it off with our very first presenter tonight. Her name is Dr. Candace Cham. Dr. Cham has a PhD in cancer biology from the University of Chicago, and she's not only a brilliant scientist, she's also the program manager for Eugene Chang's lab, and she's going to present to you about fiber supplements and gut health, even when you're eating what we call Western diets. And you can see a list of some of the other brilliant folks that you're going to learn from tonight, and I'll walk you through their introductions as we go. But with that, I'm going to hand it off to Candace.
Thank you so much, David, for that introduction. Welcome. Our interest in the Chang Lab is to study the gut microbiome and its role in health and disease. The gut microbiota rely on the food that we eat so that they can grow and thrive in our intestines. As a result of this growth, they make byproducts, or what we call metabolites, that our bodies use for our own physiology. So it's well known that a well-balanced diet consisting of high fiber and low fat is the key to eubiosis, or a healthy gut microbiome. It's the diversity of foods that provides fiber and nutrients such as oligosaccharides that promotes the growth of beneficial bacteria. Beneficial bacteria produce metabolites that positively regulate our health. On the other hand, Western diet, as delicious and irresistible as it is, can lead to a dysbiosis, or an unhealthy gut microbiome, and it does not promote the beneficial bacteria. And what it does is it can lead to GI symptoms, increased risk for IBD, heart disease, diabetes, etc. So what if you can eat a fiber bar or a scoop of human milk oligosaccharides on top of a Western diet? These different types of fiber or human milk oligosaccharides can support the growth of beneficial bacteria. So what if these supplements on top of a Western diet can delay or prevent the negative effects of having that Western diet? So can you have your cake and eat it too? The hypothesis that my studies will be testing is whether supplementing a Western diet with nutrients that are normally lacking in the Western diet will delay or reduce its negative health effects by promoting the growth of beneficial bacteria. So there will be two arms of this study. The first will be a human study, and the second will be a mouse study. So human subjects will be asked to take a fiber and human milk oligosaccharide supplement on top of their normal Western diet. And we will be testing the effect of these supplements on their gut microbiota, as well as their blood chemistry. In a more rigorous and controlled mouse study, we will separate mice in different groups and give them different diets. And we will be testing their stool, looking at the effects of each of these supplements on their gut microbiota. In addition, we will also be checking their metabolism, putting them in metabolic cages. And so we will be looking for the increase of beneficial bacteria as well as the increase in the positive metabolites in these mice. And as always, we are so grateful for GIRF's constant, generous support. It's invaluable and enables us to do studies like this that are outside of the box. Thank you so much.
So with our next presenter, it's Dr. Orlandon DeLeon. He is a research assistant professor and has his PhD in microbiology and immunology from the Medical College of Wisconsin, just across the border up north. And he is an incredible collaborator with many of us doing some work related to a number of topics that are funded by GIRF. And he chose this one related to circadian rhythms in our gut. Landon, take it away.
Thank you so much for that, Dr. Rubin. And thank you for all of your time and, of course, your support to hear about some of the work we're doing. And we're really investigating, could disruptions in the gut's internal clock, the microbiome, be driving IBD? So let me tell you why circadian rhythms matter. So you've probably heard in the public domain, circadian rhythms and its ability to control your sleep-wake cycles. And this is a very well-known biological process in the host side, in the humans. And it's so important because it controls not only sleep-wake, but when you eat, when you exercise. And that's very important, right? All of those things can affect a lot of different metabolic and immunological consequences. You might be surprised to know that your gut microbiome actually has its own circadian rhythm too. Your gut microbes can tell time. We can remove them from the body, and they actually keep time in a 24-hour pace. So we wanted to ask the question, in IBD, do IBD patients have disrupted microbial rhythms? Do their microbiomes have a disrupted sense of time, which has never been explored before? And could that affect disease and make it worse? So how do we examine this? How do we examine the IBD microbiomes and their circadian rhythms over time? So we take non-IBD and IBD patients, and we can take their stool and we put them into these bioreactors, which are essentially containers that allow us to grow continually the microbiomes. And this lets us sample the microbiomes at high frequencies every couple of hours, which you can imagine is really hard to get from humans directly. Imagining to tell someone to go on command every couple of hours is really hard. So what we do is we take those samples, then we do the circadian sampling and look at a bunch of different omics, which is really multiple techniques we use to see who's there, how much they're changing over time in composition, the different bacteria, and what they're producing over time. And what this looks like, this machine in the lab, this is what one of these, is it showing up?
Not yet. There you go.
Oh, okay. This is what one of these fermenters look like. And we can sample from this over time, which just really means there's a lot of really sleepy graduate students when we do this. So we've actually finished collecting these data and we're analyzing it now. I'm going to show you a little bit of a sample of that data. These are metabolites in the row, so different molecule that the microbiome is making over time. And this is sampled every several hours over 48 hours, so 2 days. And you can see when it's green or yellow, it's high, and then it comes down in blue and then comes back up. And you can do perturbations in these systems, like add fat. This is palmitate, and you see that these rhythms are disrupted. So we're seeing not only how nascently or how at basal level, normal levels, IBD microbiomes have good or bad circadian rhythms in their own microbiomes and what they're making, but also how they're responding to different dietary components like palmitate. With that, I'd really just like to thank GERF for all of its funding, but also the support from the other collaborators who are on this project, including Dr. Chang, Dr. Ashley Sidebottom, who's working in the metabolomics facility to generate this beautiful data, Dr. Brian Pendergast, who's an amazing circadian biologist, Karen Lowland's a technician, and Mariah Wilson, who's a graduate student. And they're really the sleepy ones in all of this. So thank you.
Thanks, Landon. So just to let everyone know that bioreactor is essentially an artificial colon, essentially. It's basically maintaining the organisms that would otherwise be found in someone's large intestine. So you're able to study this. And obviously, the relationship between our gut microbiome and sleep habits is of great interest. And it may explain why when people travel, it has to do with the jet lag they experience as well and some of the other things. So we'll wait for some questions about your presentation in a moment. Thank you so much. Our next presenter is Dr. Matthew Odenwald. Matt has both his medical degree and a PhD. His PhD is in cellular and molecular biology from the University of Chicago. He's also a liver specialist, a hepatologist, and he's been doing some work related to the bacteria in our bowel and how they interact with the liver. So Matt, take it away.
All right. Thank you, Dr. Rubin, and thank you to everyone for having me speak this evening. To start things off, I'd like to thank GERF for your ongoing support of our GI section, as well as the work that I'm doing. And so, as Dr. Rubin mentioned, I'm a hepatologist, so I focus on diseases of the liver. So what's the liver? It's a solid organ that's about the size of a football, and it sits in the right upper part of your abdomen. It has lots of functions, and this includes detoxifying blood that comes from the intestines, making proteins that help with immune function, making bile for nutrient absorption, and making proteins that help blood clot properly. And with all these different functions, you can imagine that patients without functioning livers are often some of the sickest patients in the hospital, and they're prone to life-threatening infections, hemorrhage, and even death. The liver is directly connected to the intestines in two ways. The first is that all of the blood from your intestines drains directly into the liver. And then in the other direction, the liver makes bile, and that drains into the intestines through the bile ducts. As we've heard from the first two presentations, trillions of bacteria live in the intestines. And many of these bacteria are commensal or good bacteria that make small chemicals called metabolites, while others are pathogens or disease-causing bacteria. The blood that drains from the intestines into the liver has lots of nutrients, but it's also rich in these chemicals that the bacteria produce and can often even have entire bacteria in it. And then on the flip side, the bile that drains in the intestines can also shape which bacteria are present and how they function. So this close connection between the gut and the liver led to my initial hypothesis that the gut microbiome might influence liver disease outcomes. And in just over about 2 years, we analyzed stool samples from over 500 patients with cirrhosis to determine what bacteria are present and what they produce. So we observed that there were reduced numbers of the good bacteria and increased numbers of the disease-causing bacteria with each stage of liver disease. And this was associated with reduced levels of the beneficial metabolites or beneficial chemicals. These changes associated with poor disease outcomes, and this included increased risk for serious life-threatening infections, the need for liver transplant, and even death. And so this is all just an association. This isn't causation, but it does lead to the hypothesis that maybe we can give back good bacteria that can make beneficial chemicals and ultimately improve outcomes in patients with liver disease. So to test this hypothesis, I'm conducting a phase 1 clinical trial in which we give good bacteria back to patients who are missing them. There's a lot of over-the-counter gut health supplements. I'm sure you've all seen them at CVS or Walgreens or your local pharmacy. But our program is different because it focuses on controlled FDA-regulated clinical trials to evaluate defined communities and make targeted therapies for specific diseases. So doing so required a dedicated good manufacturing practice facility that we actually have at the University of Chicago within the Duchossois Family Institute. And this enabled us to produce live biotherapeutic products with quality and consistency that's needed for FDA regulation. So I've shown a picture of this facility as well as some of the staff that works in the facility, This is on the 6th floor of the Rubloff Tower. This was an area that was previously an ICU, and it's 2 floors up and just down the hall from Dr. Rubin's office. My immediate goal is to advance an IND application that allows us to move this into clinical trials. And we've completed this and actually started enrolling in our first clinical trial. So I'm starting with liver disease. I'm a hepatologist, and I have preliminary data supporting this avenue, but this can create opportunities to rationally restore the microbiome in a broad range of conditions. These include cancer and responses to cancer treatments, autoimmune conditions, colon cancer, and even inflammatory bowel disease. So thank you for your attention, and thank you again for joining us this evening.
Thanks, Matt. That was terrific. Our first three presentations were all about the microbiome. So having said all that and helping you understand a little bit more about the unique work going on related to this in many different diseases, we're going to shift gears now and move on to our next presenter. And it's my pleasure to introduce Dr. Bradford Chong. Dr. Chong is an assistant professor of medicine. He's also the director of our Pancreatic Center of Excellence at the University of Chicago. We were lucky enough to recruit Dr. Chong when he completed a pancreas fellowship at the Mayo Clinic, and he's been an incredible leader in our center in this important space of the pancreas. Bradford, take it away.
Thank you very much, Dr. Rubin, and thank you to GERF for their support of this study on pancreatic cancer outcomes and social determinants of health. This project was done with collaborators institutionally as well as externally with the University of Illinois Healthy Regions and Policies Lab. So pancreatic cancer. Pancreatic cancer will be the second leading cause of cancer-related death in the US by 2030. And we've learned that social and systemic factors are likely associated with delayed diagnosis, decreased access to therapies, and overall worse outcomes. Leveraging geospatial data and social determinants health data at population census level may lead to better understanding of the interactions between geographic and social factors that facilitate early diagnosis. We recently published our findings this month in the Pancreas Journal. The aim of our study was to determine associations between travel distance, travel time, and early stage pancreatic cancer diagnosis. We looked back between 2012 to 2022 of all patients who were diagnosed at the University of Chicago Medical Center, and their commute to the hospital was calculated using travel distance and car travel time using travel time isochrones. Our primary outcome was early stage 1 diagnosis. Our hypothesis was that burden of travel negatively impacts timing of pancreatic cancer diagnosis. We included in our analysis important factors, including age, insurance status, and an index called the Area Deprivation Index, which is a population census level index that measures socioeconomic deprivation at the neighborhood level. For residents within city limits, we calculated public transit time as well. Next slide. So the next slide, this is a geomap of all pancreatic cancer patients diagnosed at UChicago and where they resided. So this is just south of 700 patients. As you can see, the yellow dots correspond with high socioeconomic deprivation. The blue color corresponds with low deprivation, and the star is the UCM Medical Center in Hyde Park. Our findings showed that, contrary to what we thought, increased travel distance greater than 25 miles and increased travel time greater than 60 minutes were associated with early stage diagnosis. Interestingly, these associations were present in low deprivation neighborhoods, but not high deprivation neighborhoods. So the conclusion was that patients in less deprived neighborhoods are diagnosed at an earlier stage despite travel longer distance and times, and that patients in high deprivation neighborhoods experience later diagnosis despite closer proximity to the hospital. And so this really underscores the need for new metrics to better characterize access to care for patients in low resource areas. And then last slide. For future directions, digital health-based cancer services, including electronic health records and patient portal systems, have been rapidly integrating into healthcare, allowing patients to schedule appointments independently, view test results, request refills, and directly communicate with providers to seek medical advice. Digital health may help overcome geographic barriers to cancer care, but better understanding of digital needs in cancer care is needed to develop digital-based approaches for improved care coordination between teams, enhance symptom monitoring and management, and overall outcomes. We'll be presenting our work at DDW on the role of digital health in pancreatic cancer. The study sought to identify predictors for MyChart utilization and to determine associations with adherence to outpatient cancer care. This is preliminary data on the right of the distribution of MyChart activities across early versus late stage pancreatic cancer in our patient population. And we're currently preparing a manuscript to be submitted for review later this month. Our transportation study also informed another pilot study, which is now being funded by the U Chicago Cancer Center, in which we'll test the feasibility of using electronic health records to measure transportation need using AI large language models and using geospatial data to map missed visits and identify hotspots for cancer center decision making. We'll also collect expertise through surveys and focus groups from our institution, including health systems leadership, several service lines, operations, about how we can evaluate existing transportation policies, identify barriers to existing intervention use, and recommendations for future intervention development. So once again, thank you to the GIRF for their support of the transportation study and the publication, which has led to additional studies and funding to continue our work.
Now we're going to move on to a study that involves inflammatory bowel disease. This is Dr. Tenzin Choden's work. Dr. Choden is an assistant professor of medicine. She's also one of our inflammatory bowel disease experts. We actually now have 9 physicians who specialize in IBD at the University of Chicago, and she's also an expert in point-of-care ultrasound, something that the University of Chicago is proud to be leading the country and participating and providing to our patients. But she has a specific interest in studying people as they age with IBD and understanding how your bodies change and how your immune system might change. So she's going to share some of the work she's doing related to all of that. So Dr. Choden, take it away.
Thank you so much. And again, thank you so much to everybody for being here this evening, sharing your time with me, with us. Today, I'll be sharing a little bit about our project, which was very generously funded by a GIRF pilot grant that's titled Point of Care Ultrasound as a Sarcopenia Risk Assessment Tool in Patients with Inflammatory Bowel Disease. So there's a phenomenon called sarcopenia, which is essentially defined as the loss of muscle mass or the amount of muscle that you have and muscle function. This is something that we unfortunately see very commonly in patients with IBD and can be seen in up to 52% of patients with Crohn's disease and 37% of patients with ulcerative colitis. And why does this matter? We think that having sarcopenia likely leads to problems after surgeries, increased hospitalizations, and worse disease outcomes. So the challenge here is that sarcopenia might not be visible on an exam. So patients can appear healthy at a normal body weight. And the current gold standard for detecting sarcopenia or this type of muscle loss is a CT scan, which is costly, has radiation exposure, and overall is just not something that can be done in clinic easily. So therefore, there is currently no practical routine screening tool that currently exists. And just to demonstrate that point, here I'm showing you 3 very different individuals, one underweight, one overweight, and one obese, who all actually have the same exact amount of skeletal muscle mass. So you can clearly see that this isn't something that we can just eyeball in clinic. So what are we doing about this? Well, we've already started using intestinal ultrasound quite frequently in monitoring IBD and disease activity in patients. So can we extend the use of this, and can a bedside ultrasound essentially replace the CT scan as a screening tool for sarcopenia? Ultrasound is quick, it's painless, there's no radiation, and it's done at the bedside, and probably adds about 30 additional seconds to an intestinal ultrasound that's already being performed. So we have been measuring the rectus abdominis muscle, or your ab muscle, with an ultrasound and comparing it directly with the gold standard CT scan. And our hypothesis is that lower rectus abdominis muscle thickness on bedside ultrasound also reflects lower whole body muscle mass and can predict adverse IBD outcomes. So some of the key questions we are answering are: 1, can ultrasound accurately detect this type of muscle loss? 2, what is the right cutoff value to diagnose sarcopenia? So we're hoping to establish an ultrasound threshold that reliably flags sarcopenia, giving clinicians a clear and an actionable number for everyday use. And 3, does muscle loss today predict worse outcomes tomorrow? This is not something that's been studied prospectively, meaning it hasn't been looked at in patients as they are continuing through their disease journey. So we are going to follow patients for 6 months to see whether a low ultrasound reading predicts hospitalizations, surgeries, or disease flares before they actually happen. And really the vision here is to make ultrasound a routine vital sign for muscle health, detecting sarcopenia early in any IBD clinic worldwide. So thank you again, and thank you to GERF for funding this.
Our next presentation is by Dr. David Zemmour, who's both a MD and a PhD and works in our Department of Pathology, which reminds me to tell you all that the GI Research Foundation funds our colleagues across the institution if they're doing work in digestive diseases, not just in the Department of Medicine or in the section of gastroenterology. We have examples of GERF funding our surgeons, our radiologists, our pathologists, our pediatricians, and many others. Dr. Zemmour is an assistant professor of pathology, but also has a PhD in immunology and molecular and cellular biology. And he's very interested in outcomes related to surgery in IBD. So David, take it away.
All right. Hi, everyone. Let me go to the next slide. How do we do that? There we go. I'm very happy to for sharing the results of the research we did that is really directly related to your support. And it's really a unique opportunity, I have to say, as a researcher. We really rarely have the opportunity to connect directly with the people supporting our research. So thank you for organizing this, and thank you for coming. So here's the medical problem that we have, that we posed a few years ago, is really related to the surgery in IBD. It's a very risky surgery. And some of you might be aware, but in some very difficult situations, the drugs don't work for controlling the disease, and surgery becomes one of the last options, especially in the context of ulcerative colitis. The problem with this surgery is that it's pretty complicated. It involves like 3 different interventions, like 3 different steps. One of them is removing the whole colon, and then you have to go back and creating a pouch, sort of to keep the feces. And then you have a third step of closing everything. So it's complicated. University of Chicago is actually a leading center for that. And we took advantage of this experience when we started this research of having more than 20 years of experience. On top of being complicated, this surgery is actually risky. And we have 10 or 20% failure rate. It doesn't sound like that much, but actually when you're this patient is the whole world, right? So we really wanted to see, can we make it better? And to make it better, we had specifically 2 questions. One is, can we identify the patients that we think the surgery is not going to work? And the second one is, can we think of new treatments to improve this success? And so, thanks to your support, we actually did research, and in this research, working with pathologists, the people who take the biopsy and look under a microscope, we actually created 2 new tools for us. And the first one is that we can take pieces of the colon during the disease, and we can look under the microscope, and now the pathologist can look and say and give you a score, sort of a risk, quantify the risk of the surgery being a failure. And so we can go from a score of 1, for example, where the risk of failure is very low, like only 2%, from like something that's actually pretty risky, where the chance is like 50%. And so on top of that, we actually improve from just these images in color here with new diagnostic tests, to improve this prediction. So that's one part where I think it's making a difference in the clinical practice today. And the other one is how can we think of new treatments? And today we hear a lot about precision medicine, and there's really exciting new technology for researchers that can have really an impact in the clinical practice. And this is a piece of colon on the left where the pathologists look when you look 100 times, and it's been 100 years that people have been looking at pieces of colon like this. It's really looking at shades of blue and pink and trying to see something in there. But what we can do in 2026 now is that we can take the same tissue and we can look at all the molecules and all the cells that are in there. Instead of having this image in pink and blue, we can have these whole movies of all the molecules working together, as I'm showing you in the right. So that's directly from your funding. And what do we do with that? Sorry, next slide. I'm trying to, yeah. So this is an example here when if you look even more into the colon like 1,000 times, then you really see all the cells, these little circles in this image, and they all have different colors because they're different cells. And then what we could do now is that look into this piece, look at all these cells. You can see it's very busy, very packed, and they are not just next to each other, they actually talk to each other. And what we found is that the way they talk to each other in the disease can predict if whether the surgery or not is going to work. And in particular, we find one molecule, IL-1 beta, and that they can predict whether the surgery is going to work or not. And there is actually drugs that can block this. And we think that like if you start trying those drugs to improve the surgery success. So I want to thank you for the next slide. Sorry, if you can. So. This is the team who worked on that. We published this paper, and really, there was your support was critical there. Thank you.
Thank you so much for that introduction, and thank you everyone for joining and giving your time today. Today I'll talk about our project using artificial intelligence and virtual reality to support anxiety and pain in our patients with inflammatory bowel disease. Patients with IBD are known to have higher rates of mood disorders such as anxiety or depression, and this is higher than the general population, even when their disease is well controlled. The cause for this is unclear, but it's likely related to complex interactions between the bowel, the brain, and the gut microbiome. In addition, we know that patients with IBD who have significant anxiety or depression also have worse outcomes. How do we address this? Well, treatment options for mood disorders include talk therapy or medications. They have limitations. And so using pilot funding from the GI Research Foundation, we collaborated with Cedars-Sinai Medical Center in Los Angeles, California, and we used the use of Zaya, which is an AI-assisted virtual reality application, which uses the Apple Vision Pro headset and immerses users in a relaxing environment while also performing talk therapy powered by an AI avatar named Zaya. We found that after a single 30-minute session with this application, patients were already reporting improvements in anxiety and pain scores. We also interviewed each of these patients between both centers, and the consensus was that this tool is very helpful. You can see a little animation over there as well. We used this pilot data to ultimately support a grant application that was very well received, and it will now be funded by the National Institutes of Health. And this is to study how this application can influence mood, quality of life, IBD symptoms, and inflammatory levels when patients are able to use this at home daily over the course of 8 weeks. And we'll be recruiting for this study soon, and You can let us know if you're interested in participating. And so with that, I just wanted to thank everyone for joining again, and thank you to the GI Research Foundation, especially for supporting this work.
Thanks, Alvin. To start with a question that was for Candace Cham. And Candace, it was the question I had for you, but it's a more generic question for all of our investigators. If a person who's joining us tonight would like to become a participant in any of these studies, what would be the best way to do it? Candace, you can answer, and then maybe I'll add to that. So we'll start with your study of feeding people donuts with fiber.
The easiest thing to do would be to contact me directly. Then we can start the screening process. Well, we first have to ask you questions about your diet and how much fiber you take in, and then also ask you for a stool sample, so we can measure your metabolites before you take the fibers or the other supplements. But yeah.
Do the participants in your study get the results of the metabolomic or metabolite assessments?
Yes.
So they actually get some feedback from you about what they participated in. So maybe we'll ask the wonderful people at GERF when they send a follow-up to all the people who joined us tonight to share appropriate contact information for those who want to participate further. And I'm sure that you'll have people who are interested. Somebody who saw your presentation tonight wanted to know a little bit more about what this type of fiber you talked about is. What is this fiber? Is it something you can buy over the counter, or is this a magic formula that you and Dr. Chang have created?
Actually, we are partnering with a local company called Ceridi Therapeutics, who have developed a fiber bar called Neurofiber Bar. The Neurofiber Bar contains many different types of fiber that are derived from whole foods like beans and fruit and other whole foods that they have then purified and put into this bar. So it's very similar to like a protein or energy bar, and it actually tastes pretty good. It comes in 2 different flavors. I've had it myself, and every bar contains, I think, 11 grams of fiber.
Okay, great. Thank you for sharing that. All right, we have lots of good questions, and we had some that people submitted even in advance of this meeting, which I have printed out and in front of me as well. So this question goes to Dr. Chong about the pancreatic cancer. First, I'll just make a general comment that seeing that map with all those dots of people who had pancreatic cancer is really powerful. You know, each one of those represents a human that had this awful disease, and so it's really striking to see that. The question, though, is how do you improve these findings? What are you going to do? What's the intervention to address these disparities that you were able to measure?
Thanks, Dr. Rubin. And part of the challenge is kind of understanding, with some of these potential interventions, like what are for example, digital health, like what are the digital care and digital health needs in our patient population. And so some of that is, with the work that we're doing now is kind of understanding, what is the utilization. So how do patients interact with the MyChart even prior to their diagnosis? And then once they've been diagnosed, how are they interacting with the MyChart, for example, and are there opportunities to leverage that? Because our data, from our experience, and we'll be publishing on this, suggests that high utilization of MyChart may facilitate like early entry into getting earlier diagnosis. And so I think there's something there, but obviously, we need to study this more. I think the other aspect of your question is related to access and transportation. And so this is kind of the approach that we're taking with the Cancer Center pilot, where we're leveraging artificial intelligence to look at large kind of data sets, patient notes, electronic health records, to try to identify who are kind of high-risk patients with transportation insecurity. And then at the same time engaging the stakeholders. So this includes patients, but also operations, health system leaders, social workers. How can we get their input to better understand what the barriers are, for patients, and what interventions will be likely to be successful in terms of the transportation gap.
And for those who are not aware of this, the University of Chicago is finishing its new $800 million cancer tower, which is in part dedicated to delivering state-of-the-art cancer care to those who are less privileged, as well as, of course, advancing the science of cancer care. And Dr. Chong is part of that effort as well, of course. This is a question for Dr. Choden about intestinal ultrasound. One of our attendees wanted to know, is ultrasound as good as endoscopy? And I presume they mean for disease activity and not for sarcopenia. So can you just comment briefly on the use of ultrasound for disease activity, just to clarify how it's used?
Yeah, so ultrasound, intestinal ultrasound for disease activity in IBD is excellent. It correlates very, very well with endoscopic findings. So if anyone, has ulcerative colitis where we're scanning throughout the colon, very useful tool. Ileal Crohn's disease, so patients who have Crohn's disease in the last portion of their small intestine, we can visualize that area really well as well. I did see in the question, somebody had mentioned an ileostomy, and I don't know if that was part of the question, but anyone who has an ileostomy or to look kind of in the middle of the small bowel, it's probably not the best tool.
Yeah. So thank you for that question. And of course, for those who are just learning about intestinal ultrasound, ask your doctor. And if you're not at the University of Chicago, we'd love to see you or help you, or your doctor can certainly send you for an ultrasound and for a consultation. Dr. Zemmour, there's a few questions that have come up for you. And I'm actually going to ask you to define what it means by saying a pouch failed. There was a question about what that actually means and how it's defined, and then I can go from there.
Yeah, it was defined in two different ways. One is that we had to remove surgically the pouch because it was symptomatic and it wasn't working well. And the other way is that the pouch was still there, but it wasn't working well, and they had to put back an ileostomy. Dr. Rubin, you can correct me because you see this in practice every day. But those were the two definitions of failure.
Yeah. And the individual person was interested in the two main reasons people end up with these continent reservoirs or J pouches in ulcerative colitis are first, as you mentioned, more commonly medically resistant colitis, when the medicines just aren't working. And the second reason is to prevent colon cancer or to treat when there is colon cancer. And it is true that there's less pouch failure among people who have their colons removed for cancer, in part because they haven't had the very resistant active inflammation, which seems to drive some of the pouch problems we have later. But understanding what's actually going on and why it happens is a really important question that Dr. Zemmour is working to answer. The last question I have before I hand it to Shelby and we stay on time tonight is just for Dr. Odenwald. Somebody wants to know, after you finish your phase 1 study, can someone buy your microbiome concoction and start taking it? And do they need to have liver disease to be able to get these good bacteria that you're manufacturing?
That's an excellent question. And the way that we're going about this, the answer is, at the moment, no, you won't be able to buy this over the counter. There's many companies that do this through a regulatory mechanism called generally regarded as safe. And so that's how all of the probiotics that you see at Walgreens and CVS go through that regulatory pathway. We're going through and testing it in specific disease states. And my specialty is liver disease, but I'm collaborating with a lot of other groups, oncologists, and as well as other groups who are studying different combinations of our bacteria in their disease states. And so our hope is to one day have an FDA-approved microbiome therapy for specific different conditions.
Will it be named after you?
I don't know. It might be the Odenwald mix. I'm not sure.
Okay. All right. Well, I'm sure people will be interested to hear follow-up on that. I'll just address a question here about mental health from one of our attendees. I will say we're working very closely with our colleagues in the Department of Psychiatry, Psychology, and Behavioral Neuroscience. And in fact, GERF has funded the leader of our gastropsychology or psychogastroenterology group. This is a trained psychologist who specializes in the psychology that's related to GI illness and specifically in her area, IBD. So we work very closely with them and we interact and study this together. And they're co-authors and co-investigators and lead investigators in a lot of the work we're doing. So thanks for that question. I know there were more questions. There's always more questions. And that's part of what we do is try to answer questions. And one question that's answered leads to 10 more. And so that's true about tonight and our attendees in the audience. And I just want to say on behalf of the University of Chicago and on behalf of all these wonderful investigators who presented tonight, thank you to the GI Research Foundation for their ongoing work for all these years, for our board, which is bigger and more diverse than ever, and for all the people who donate to support the work that's going on. This was just the tip of the iceberg. This is just a smattering of some of the research that's being funded by the GI Research Foundation, among many, many other projects that we would love to share in a future meeting. So if you like this, please give feedback so that we can plan more. And with that, I'm going to hand it off to Shelby Katz to close our evening.
Thank you, Dr. Rubin, and thank you so much to our presenters this evening. We are incredibly proud to support your work and inspired by the progress you are making. These discoveries that you're pursuing today are the breakthroughs that patients will depend on in the future. And love the additional questions. As Dr. Rubin said, we'll have to do this again. At the heart of the GI Research Foundation's mission is funding research, sharing it, and when we understand it, we learn, we gain hope. Hope that care will improve, hope that prevention is possible, hope that one day we can imagine and realize a world without digestive diseases and GI cancers. So we want to thank you so much for being here tonight. Your presence really matters. We want you to leave with a deeper understanding of the work we support and a stronger connection to the role you play in advancing it. This is not just a one-night effort. It's a year-round movement. We have a few upcoming in-person events in the Chicago area. On May 30th, we invite you to join us at our annual ball as we celebrate the extraordinary leadership and generosity of longtime board member Howard Grill. And then on August 31st at our annual golf classic at the Glen Country Club, featuring PGA Pro Chip Beck. We hope to see you at future educational events as well. And you can learn more by visiting our website at the giresearchfoundation.org. Please stay connected with us, sign up for updates, follow us on social media. And when something inspires you, we ask that you share it. Your voice extends our reach and amplifies our mission in ways that simply we cannot do alone. And we appreciate it. I want to say tonight was about learning, connection, and possibility. Perhaps it inspires you to consider getting more involved in the GI Research Foundation or making a gift. You can use the QR code on the screen to learn more. We appreciate your interest in advancing science. And good night.